welcome to VMworld 2015, and I know this session's on 3 p.m., which is like, siesta time for some of us. So, but I hope what we have done is we have demos in between so that hopefully that'll keep us all awake. Okay. So typical disclaimer. So this you probably see in every session. And so this is our agenda, right? We want to introduce ourselves first, and then we talk about how there are all these challenges for traditionally virtualized business critical databases. We talk about databases in general, but the examples we show would be Oracle based, but it applies to both SQL and Oracle. And we will talk about, particularly, we're going to focus on backup and recovery, which has always been a pain point on VMware, and how vVOLS can help with that. We talk about vVOLS as a game changer, and how we will show you demos, that the 3 use cases we show you as demos, and then we conclude. So you can ask all your questions to the end so that we can flow through the presentation. Right? So I am Mohan Poteri. I'm a professional for 20 years. I've been a sysadmin, architect, and now I'm at VMware for 5 years. I focus on business critical applications, and I also focus on vCenter. So, and this kind of gives you a background. And Sudhir will talk about.
Thanks, Mohan. So, welcome, guys. Good afternoon. My name is Bala, and I've been an Oracle DBA, an Oracle architect for like 20 years. I joined VMware in 2012. I did services for a year and a half, and then I joined the Global Center of Excellence. I have a pre-sales role. So basically, my primary focus is Oracle databases.
Okay. So if you look at, let's look at all the common problems when you virtualize a business critical database, right? First of all, when it's a business critical database, SLA is very important. So what happens is the database is where all the data for your critical application is running. And if it needs to be performing at a consistent level throughout the day, and through critical periods in your cycle. It could be like month-end, quarter-end processing could go through your database. So it is very important that for when you have a business critical database, you are adhering to strict SLAs. So a lot of the things that potentially impact the database typically are things like nightly backups, when you have batch jobs running. So we need to be able to have a solution out there where when you virtualize your business critical database, all these things that happen against the database does not degrade its performance or impact it in such a way that the SLAs that the business depends on are kind of not met. So that's kind of the first bullet point there. Typically, if you look at daily operations, right, you have backup and recovery. So backup and recovery, you have usually a backup window, right? And it happens in a lot of companies like 11 p.m. to 2 a.m., for example. And so your backup should run within that and finish within that without impacting performance of other things like batch jobs and other things running at that time. So it's very important for the backups to complete in a set window. Then you look at things like, for example, if you have a ERP system, you have a database, and you would typically take the database and refresh it to your test and QA cycles. So there's a lot of impact that can happen if your the database is being used for cloning and refreshing. It could potentially impact the performance of the production database. So it's kind of very critical that for cloning and refresh as well, you have a very well-performing database and a performing infrastructure such that it does not impact production. So these are kind of typical challenges, right? And a lot of times we need to balance, we need to be able to deal with that. And then the other aspect is sometimes you might have different kinds of databases on your infrastructure. You might have certain databases that are really critical then some are highly critical, and then medium, things like that. You need to be able to host all of these in a common infrastructure, but at the same time be able to provide the characteristics and capabilities that particular tier of databases require. So that's that's very important as well. And the last but not the least is like the DBA's never-ending debate, right? So we had file systems initially, then raw devices was a common methodology. Raw devices, there's a perception that was faster. So the DBAs would argue with sysadmin saying, give me raw devices. So that was a big challenge for the virtual admin. We had to, when you provision raw devices, there's a lot of other things that you have to maintain, a lot of extra things that your operational team needs to do to provision this. So, and also there's argument VMFS versus RDM. Bala,
Sure.
you want to say something about it?
Yeah, I mean, this is typically a never-ending debate, right? File system, raw, which would you pick? And I would, as a DBA, pick raw devices, right? And then at some point in time, Oracle deprecated raw and said, okay, hey, all hail ASM, right? And the Oracle troop, they went towards ASM. And now when we are virtualizing Oracle on vSphere, right, there's another debate. VMFS versus RDM. Should I choose VMFS? Should I choose RDM? What are the use cases? So, I'm sure you guys must have been caught in this debate many a times, trying to decide which side of the spectrum that I should take, right? And the follow-up conversation will explain a bit about that.
So now let's look at backup recovery and cloning, right? We mentioned those are like some of the major challenges that virtualized databases have. So if you look at that, so you have, as I said, there is short backup window, right? So we want to back up our database with least production impact. So since the backups are reading off your database storage and writing to other storage, we want to make sure that it's not impacting production in any measurable way, right? And then we want to make sure that our backups are recoverable and repeatable. That means the backups are of no use if you cannot recover from them. You need to make sure that you're able to recover from your backups. And also, you need to be able to repeat the backups nightly basis or on a weekly basis and without it failing. So that's very important, right? And if you look at I want to talk about 3 different types of backup, right? That is the application level backup. What is application level backup? It could be like a SQL Studio doing a backup of a SQL database, or it could be RMAN backing up Oracle, right? They are provided by this database vendor themselves, and it's application consistent. The backup is and it's like what do you call it? That's what we call an application level backup. Then we have vSphere level backup, right? We can use snapshots to back up databases, but there are some challenges with that. We'll talk about those challenges as we go. And then there's storage level backup, where snapshots. So we'll also talk about that in detail in the upcoming slides. For large databases, the DBAs typically prefer either the DB level or the storage level. That's what they trust. If VMware is in between layer, they don't really trust it. They say, you know what, all my writes in, am I able to be able to recover? So the database snapshots, if we say we back up the database with a snapshot of VM, there was very little credibility in the past. So if you look at what are the factors affecting the duration of a backup, you have the level of backup, right? So there's the level 0, which is like a full backup. And then you have incrementals, you have consolidated, cumulative backups, right? So depending on the type of backup, the duration changes. And with kind of the sizes of the database that we have currently, level 0 backup is something that you rarely do. You do it once, and after that, it's all about incremental backups that are become made cumulative over time. Then what other thing that impacts is how much is your data changing on a daily basis. So the data change is what is going to impact the size of your backup. The incremental backup is actually capturing all the changes that happen to the database during the time period between the backups, right? So data churn impacts. And the other thing is backup mechanism, right? Tape backups are kind of obsolete, but they're still there for archival and other purposes, but the backup mechanism is very important. Tape-based, there's disk-based, there's compression, and then there's other parallel streams as well, right? And so putting it all together in the end is the underlying infrastructure. Like if the backups are flowing through your SAN, how good is your SAN? If backups are flowing through your LAN, how good is it? How big is the pipe? What other things are happening at the time? So these are all the factors that impact your backup, right? So now, if you look at, we want to define certain things, right? We want to define what is a database consistent backup, right? A database consistent backup is what, in the case of SQL, would be a SQL Management Studio backup, or where it actually running a VSS queuing operation, or it could be RMAN, where it's kind of making sure that the same SCN, which is the same point in time, is used when backup is run, right? And so the kind of that comes, first level comes from the database vendor themselves, like I showed earlier. The other things that we can do, right? Sometimes what the database vendor provides might not really suit your needs. You can gain some efficiencies by doing it yourself, right? That's what we call the user managed database. So we can have a hot quiesced backup where the DB is placed in what we call a quiesced mode. It could be VSS or it could be hot backup mode in Oracle. And then you back up your database, you take a snapshot at that time and back up your database with that. What happened here?
Something happened up here. Yeah, high availability. And DR2, so yeah.
Let's see. Let me try to put it back in, maybe.
You hot? Click on 3, click on 3. This is 3. Good. So this is the demo that you guys have been waiting for, right? Yeah.
Okay, that's the demo.
No,
okay.
no, that's, yeah.
Okay, let's see.
Go back to the next one. Watch. Go back to
See.
Yeah.
See the computer.
But you know what? While we are waiting for this to get fixed, there's one point I wanted to make, right? So Mohan spoke about 3 levels of backup, right? 3 levels where you can trigger a backup. The application level, the virtual machine level, the VM level, and the storage level, right? See, I do have customers who also use VMware Snapshot for Oracle database backup, but VMware Snapshots are not essentially backup mechanism. They're not for backups, right? And the reason being, there's a KB article that talks about there's a brief stun period. So let's say on a virtual machine, you have an Oracle database, right? And you take a virtual machine snapshot, right? As long as you don't delete the snapshot or coalesce the snapshot during production hours, you're good. But let's say if you do that, bad things happen to you, right? What happens is there's a brief stun moment, and let's say at that point of time, some people are trying to access the database, you're running a big bad job, right? Your database potentially might crash. So that's why we always err on the side of caution, especially for business critical databases, and say we don't recommend VMware Snapshot for Oracle databases. But I thought I'd just make a point there. Come on. There was a guy who was here, right? Can I run it off this one?
Is it the same step on here?
I'll run it off this one. It's okay.
You have a copy?
I have a copy.
Sorry, guys. Nothing we could.
Do you want to,
If you can just swing that over here, yeah, please.
is that the right one?
Yeah. No, that's not.
Just said, like it's
Let me change this.
Good. Yeah, we're back on. See? Be prepared. Be prepared. Right. When it comes here, right out of the presentation, escape to the demo.
Great.
This is 4. This is 4.
Okay.
Come. leave it. That's it. That's it. Good. Don't touch it. Teamwork.
Okay, so I keep losing this. Okay. So now we have.
Mic.
Okay. So when we have user-managed backups, right, we have quiesced backup where we turn on VSS or we use Oracle backup. And then we have crash-consistent backup where we don't do anything, we just back it up. But there are certain things, certain conditions that need to be met, very important. The database vendors will not support you if the conditions that we have, the bottom 3 points you see there, you need to make sure that conditions are met. It needs to be database crash consistent at the point of the snapshot, write ordering is preserved. That means your storage is writing in the order that it's expected to write it. So that's kind of very important, right? And I got to advance it this way now. Okay, so the backup methods in consideration. So now with the massive data growth, we have all these multi-terabyte databases, right? And so like solutions like RMAN or SQL backup, they do provide you with a lot of capabilities, but they're not always the fastest. Because they're happening at an application level, they actually take a lot longer the backups could take a lot longer. So that's kind of one of the drawbacks of application level backup. And we look at snapshots at the VM level, a typical snapshot could potentially stun or freeze the VM, which is a bad thing for a database. It could potentially cause your application to go out and it not being able to, the database could be unresponsive when the stun is happening. So that's very important. So so snapshots are not necessarily something that can be trusted in the traditional sense. And then you have storage-based snapshots, right? When you have storage-based snapshots, it doesn't impact your infrastructure. It's actually happening at the storage level. But typically, the way we've deployed VMs in the past, there'll be a lot of VMs running on the same LUN. So when you take the data store level snapshot, all these VMs are showing up in your backups where you're not able to separate them out. So that's kind of the drawback in the traditional storage-based snapshot, right? So, and when you look at cloning, the same issues, right? You have application level cloning, you have database level cloning, and you have, the DBAs typically prefer the database backup-based cloning or the storage level cloning operations. So when you clone multi-terabyte databases, you have, there are issues with the underlying infrastructure. The VM level, right? The VM level cloning would be ideal, but that sometimes when you have multiple VM decays, to stun a VM and have all those VM decays to come and sync could take a lot of time. So that is a problem with the traditional VM snapshots. The storage-based clone would be the fastest, right? Because the storage, it's happening behind the scenes, and it's happening at the LUN level, and so it's the fastest. So, but the problem with it currently as it's defined, there's no VM decay level granularity. You have a lot of VM decays in it and everything is included, right? So what if we can combine the two, right? If we can combine VM level, the advantages of VM level snapshots along with the advantages of a storage level snapshot, you get the best of both worlds. You kill two birds in one stone. And so that's kind of what vVOLS can give you. So, Sudhir, carry on.
Yeah, so pretty much like what Mohan explained, right? You have the capability of triggering a backup or a cloning operation sitting at the virtual machine level, right? But the snapshots are created all the way to the storage. It's not a VMware level snapshot. It's a storage-based snapshot, and that's what vVOL, the capability of vVOL brings to the table here, right? Long live vVOL. So pretty much, just let's take a minute and let's talk about vVOLs, right? So basically, your virtual volumes are a storage management and integration framework. What it does is it enables you to run your array operations, right, on a virtual disk level, right? Virtual volumes are part of the VMware SDS, software-defined software-defined storage, right? And typically there are two key elements to the SDS, right? You have the control plane, right? You have the policy-based control plane, and then you have the virtual data plane. So basically what it means is you are separating the data and the management part of it. I'll give you an example. You have a data store, let's say a fiber channel data store, or you have an FCO, or an iSCSI, or an NFS data store. it is an NFS data store, which means the protocol is bound to the storage, right? So there's no way you can delineate the protocol from the storage, right? But what if you had the capability of saying, I want to pick a protocol and I want to pick a storage and say, you know what, X protocol with Y storage. Now, wouldn't that be fun? That's one of the capabilities that vVol brings to the table here, right? So pretty much on a very high level, vVol comprises of three key elements, right? One is, the first one is a storage container, right? The second one is protocol endpoint. The third one is VASA provider, right? I won't go much detail or much deep into these. There are sessions that are actually deep dive vVOLS sessions that I would direct your attention to, but I'm going to talk about it on a very high level, right? The storage container is basically a bucket. It's basically a bucket of virtual volumes, right? The protocol endpoint can be a LUN, a device for fiber channel, FCOE, iSCSI, or a mount point for NFS, right? That's basically a conduit or a gateway through which your SCSI commands, right, that would go from the virtual machine of the guest to the array. And VASA provider is the management control plane, right? What happens is through the VASA provider, so let's say if you pick a storage, right? Once vCenter talks to the storage through the VASA provider, the storage capabilities are made inherent to the vCenter. So then the vCenter knows, okay, you know what, this storage is capable of this, these are the metrics, these are the capabilities, and I would want to use the storage this way. So let's talk a bit about the Oracle vVOLS setup that we had in our lab. So we used a SANBlaze Virtual LAN 7.3. It's a virtual appliance, and by the way, it's one of the first companies to be included in the VMware Certified Compatibility Guide. So we called our virtual machine Oracle vVOLS, and then I have a couple of demos that we would run for you here. We used OEL 6.6, yeah, 2 vCPU, 8 gigs of memory, and Oracle 12c. And the only other thing that we did was we installed VCLI, the VCLI package on the operating system. But there was nothing fancy-dancy that we did with the operating system. Pretty much a vanilla installation of the operating system. We had the Oracle database set up, right? Of course, you would have to inculcate the best practices. But the only extra thing that we had to do was the VCLI package on the guest operating system. So the way SANBlaze works is, right, it creates something called a subLUN. It's basically another word for vVol, right? It creates a virtual volume for every VMDK. So in this example, in this virtual machine, the Oracle virtual machine, we had 5 VMDKs, right? SCSI 0 had operating system, Oracle. SCSI 1 had data. SCSI 2 had FRA, and SCSI 3 had redo. So basically 5 VMDKs. And the way SANBlaze works is you have a vVol or a subLUN for every VMDK. You would see there were 2 extra subLUNs created as well when we powered on the virtual machine. The 2 extra LUNs were for the config, that's your .vmx file, and one was for the vSwap. But apart from that, there is a vVol for every VMDK, right? And we did not use any storage-based tiering. We basically used the default tiering for the initial design. And when you log on to the virtual appliance, the SANBlaze virtual appliance, and if you run the command, which is basically grepping for the subLUN, what you would see that the number of subLUNs are 7. So I spoke about 5 VMDKs, and I spoke about 2 extra, one for the config, one for the vSwap. So keep that number in mind, right? And there are 4 use cases that I would like to that we would like to cover here today. The first use case is the database consistent backup and recovery using VMware snapshots with the vVol capability. The second use case is the crash consistent backup and recovery, again using VMware snapshots with vVol capability. The third case would be cloning a database. The fourth use case, which my colleague Mohan would run, is provisioning a virtual machine, right, using storage-based policy management. So let's look at the first use case. So what I will do is I'll talk about the use case and I'll show you guys the demo. So that way you guys will, you'll have a good understanding here. So database consistent backup and recovery, that's the first use case. So primarily for this use case, we had 3 scripts, right? Well, as the name, yeah, the clicker.
Clicker won't work for this.
Okay.
Clicker works only with this.
Oh, that's okay. All right. So primarily, as the name suggests, right? So we had a hot backup script. So what the hot backup script does is it puts the database in the begin backup mode, right? It has a VCLI callout, right, which basically takes a snapshot of the virtual machine, right, and then it ends the backup. The second script clones a virtual machine from the snapshot, and the third script, which is the DB consistent recovery, right, it basically recovers the database manually. See, what happens is with the database consistent backup, when you place your database in a begin backup mode and an end backup mode, as you guys already know, you would have to do media recovery. You have to recover the database. And that's different from the crash consistent recovery, which I will talk about in the second demo. So that is pretty much what the hot backup script looked like. All we did was we did a begin backup, right? And I don't know if this is going to work. Yeah, a begin backup. We had this snippet of code. We basically goes and creates a snapshot, and we did an end backup here. That's the hot backup script. And then once we ran this script, what we found was you have 12 subruns. Initially, when we started off, we had 7 subruns. Now we have 12. So the new extra 5 subruns are for those snapshots. Remember, we had 5 VMDKs, 7 subruns, 2 for the config and the vSwap, and now we have 5 extra for the Oracle VMDKs. The script, which is the new virtual machine from snapshot, basically clones a virtual machine from the snapshot. And this is the snippet of code that basically does the recovery. So all we had to do was we had to start up mount the Oracle database. We said, okay, recover the database until cancel, until SCN time. You have many options to do that. Alter database open, and then if you have a look at it, it did its media recovery here. Yeah. So let me go ahead and run a demo for you guys. Yeah.
Yeah, let's do a demo.
Watch. I basically have to switch. So apologies for this, but let me see if you guys can see this. No, I can't maximize it. All right. This is what it is. Okay, so this demo basically consists of 3 parts. One is the database consistent backup. Another one is the crash consistent backup, right? And the third one is the cloning of the Oracle database. Let's look at the very first demo, right? So we start off with the Oracle, the Oracle virtual machine, the VM which has the Oracle database in that, right? And this screen shows you that we have 5 devices, 5 VMDKs to start with, that houses the Oracle databases. Again, SCSI 0, SCSI 1, SCSI 2, SCSI 3, the OS and the Oracle UO1, which is the Oracle binaries on SCSI 0. The 1 is for data, 2 is for FRA, and 3 is for redo. So you have 5 VMDKs.
And we're also following best practices by having multiple SCSI controllers for a database virtual machine.
Very good point. So pretty much our best practices is, you have 4 SCSI controllers per virtual machine, right? Why overload one SCSI controller with so many VMDKs, right? For load balancing purposes, use all 4. And especially for Oracle databases, we recommend using PV SCSI controllers. And you get that using the VMware tools, when you install VMware tools. So that's a screenshot of the SANBlaze, the management portal. And same command, when we run the same command, you would see that you have 7, I don't know if you guys can make out the number, it's 7 subruns. And if you look at this, so like I said before, this is a database consistent backup, which means the database is up and running, the listeners are up and running, the ASM is up and running, right? And then we run the hot backup script that basically puts the database in a begin backup mode. It takes a snapshot, does an end backup. Right?
And the snapshot is a VMware snapshot.
It's a VM level snapshot. It's a VM level snapshot, but the snapshot happens at the storage. It doesn't happen at the VM level. So let's go and see if the snapshot is created. And it is. So we had a snapshot. We named it as DBC snapshot. And let's look at the number of subruns. That was 12. The difference is the 5 subruns for those snapshots. And the second part of the demo was we had to run a script that basically clones a virtual machine from the snapshot. And that was the PowerCLI script. So we ran that. And if you look at vCenter, you could see that the cloning operation happens here. It's completed. Let's power up. Let's power up this puppy. And let's see what happens. So the third part of the demo is you have to run the DB consistent recovery, which is basically a script that would go in and say recover database, alter database open, right? Voila. Media recovery completed, and we have a fully cloned database from a database consistent backup. So this is end of demo 1. I may have to switch back to this. Yeah. All right, so case 1. So use case 1, we spoke about a database consistent backup and recovery via VMware Snapshot using the power of the virtual volumes, right? Case 2, crash consistent backup and recovery. And why are we talking about it? See, typically if you walk into an Oracle shop, right, the DBA says, I need to have end backup, I want to have begin backup, I want to have end backup, right? I want to have these two redo markers in the redo stream because that's how Oracle recognizes it, right? At some point of time, we had storage vendors who went to Oracle and said, you know what, we would also like to have a crash consistent, the capability of having crash consistent snapshots. So basically, you have an Oracle database running, I would just want to go take a snapshot of that. I don't want to go quiz the database, I just want to take a snapshot of the database. And is it possible for me? Do you think you guys will support it if we do that? And the answer is yes, as long as you follow 3 rules. There are 3 rules. First, right order fidelity. Every block in the file, in the snapshot, has to be in the right order, right?
He's got a question.
Yes, sir. There's a mic up there. Yeah, please.
Is there anything different with the engineering now of snapshots and vVOLS? We've had issues when you create a snapshot, the delta file grows and it's opaque. You have no way to look at how big that delta file is unless you go in the console, and we've had issues where it freezes the storage volume, or if you had a discrete separate backup VM where they export logs, you've already pre-allocated how much size. It's a management issue. That's what the problem I have with snapshots of databases, because you don't know what the rate of change,
right,
and this delta file can blow up.
Here with vVOLS, there's no delta files. So as you saw, right, the number the snapshots happen at the storage level. So instead of creating a delta file of your VMDK, you actually have a snapshot at the storage level. So that's how this is done. So it's different. And so the problem is moved from VM level to the storage level. So, and storage is usually, yep.
So it depends upon the LUNs. So if the LUN is from the reserved LUN pool or a snap pool, yes, you can do that. See, what happens is, when you look at a vVol, when you look at a virtual volume, it basically looks like a data store, right? So if you go into ESXi, right, and if you go into the data store and say ls minus l, you will see all the VMDKs, but you would not see the flat because they basically reside on the storage side. So your deltas, your virtual volume, your deltas and your base is basically on the storage side. But to answer your question, yes, you could have a reserved LUN pool or a storage pool from which you could assign your deltas from.
So you have to manage your storage carefully, obviously, and also the storage can signal your virtual admin that it's getting full. So that's one more thing. So it gives you that visibility.
Yeah. Right. Let's look at the use case 2, right? So pretty much the only difference between the crash consistent and the database consistent backup and recovery is I'm not putting the database in a begin backup or an end backup mode. I'm basically taking a snapshot of the database, right? So, and this is the crash consistent backup. So what we did was, the first script would basically take a snapshot of a running database. The second script, which is the same script, would create a virtual machine from the snapshot, and the third script would just start up the virtual machine, which would then start the database up, right? So I may have to speed it up a little. Yeah. So okay. I'm sorry about this, but home, yeah. So this one. All right. So let me. I think you guys have already seen. Okay. So this is the crash consistent. We run the crash consistent script, which basically takes a snapshot of the Oracle database. You go to vCenter, you look at snapshots. Voila, the snapshot is here, right? You look at the number of subluns is 12 subluns, same equation. You run the script that basically creates a virtual machine from the snapshot, right? Cloning operation is completed. You start up the virtual machine, the cloned VM, and then when you go up there and you look at that, the database is not started. It can be set to automatic, but typically DBAs don't prefer that. And you can run your crash consistent recovery that basically opens up the database. It does this instance recovery or crash recovery, right? It does all the recovery of all the threads. Basically, in this case, it's a single thread, right? It does the instance recovery of a thread, and voila, the database is up and running. So This is our use case 2. Let me switch back to. So the third use case is the cloning of an, So basically cloning a database virtual machine, right? So typically this is one of the hardest tasks that DBAs have to perform. Hey, I want to clone of these Oracle database, right? Can you refresh this test environment from a production environment? I mean, I've done that so many times when I was an Oracle DB and architect, right? So there were scripts that we had in place that basically goes and does it. And it is time taking, it is arduous, but of course, if there's any way to speed that up, that would be great, especially given the size of the database, right? So same use case here, right? All we do is we take, in this case, we do not run a script, we just do, we take a clone at a vCenter level. So we go into vCenter and say clone a virtual machine, which is basically the same as running the script. That will basically that will clone a virtual machine, and when the database starts up, it starts up automatically. It results in a crash recovery or an instance recovery, and the database comes up. So let me quickly switch to the demo of. Right.
5 minutes.
Yeah. All right. So again, let me show you the highlights here. Number of subnets are 7. The database is up and running. We go into vCenter. Right, and we click on clone, we say clone to virtual machine, and I create my virtual machine. I pick the compute resource, I pick what storage I want, and then Mohan will cover the storage-based policy management.
So this thing, one thing you have to remember is you should choose the same data store. That is the vVOL compliant data store.
Right. And then when you fire this up, so the virtual machine is cloned, and we just start the database up, and the database comes up. So, go ahead. So we'll have, yeah, Mohan. So, hang on, there's one thing I wanted to get. So yes, the Oracle vVOL, it is a game changer, right? See, pretty much what we were able to demonstrate successfully is you are able to trigger, right, a backup. Database consistent or crash consistent or cloning operation sitting right from the virtual machine. We did not do any kind of Oracle RMAN cloning. We were sitting right at the virtual machine level. We ran a cloning operation or we ran a backup operation, right? And we saw that the snapshots were created at the storage level, which is very critical. It's not created at the virtual machine level. So we were able to actually kill 2 birds with one stone. These are some of the vVOL sessions that definitely I would recommend you guys to go to, right? So they would go, they would do a deep dive into some of the vVOL concepts.
Okay.
So we'll have Mohan talk about the.
So last feature that we really want to talk about is storage-based policy management, right? So this is the foundation of SDS. That is, so the it provides you the storage policies. What is a storage policy? We mentioned one of the use cases where you have different types of databases that require different kinds of storage, and how do you provision that in a vVOL infrastructure? So what happens with vVOL is it exposes storage capabilities to your virtual infrastructure, and you as a virtual admin are able to see those features. And then you're able to pass on, you're able to create VMs based on the profiles that are the requirements for your customer. Customer might say, I need a high performance database, I might need snapshot capability, I need this capability. So those kinds of capabilities are exposed by vVOL to the virtual infrastructure, right? And so this kind of helps us overcome a lot of traditional challenges, right? It provides differentiated service levels. And also, as I mentioned, if you're running out of storage, actually the storage array tells the vCenter I'm running out of storage. In the past, it used to be a communication between the storage admin and the virtual admin. So that's a big thing here as well. So I just want to show you an example. We have created 3 containers in the SANBlaze array. Each of them have different storage profiles: gold, silver, bronze. And these, as you look here, you would see that there are 3 data stores associated with it, and these data stores have those characteristics, right? And if you go here, you see in the case of a gold, for example, the read IOPS, the write IOPS, latency, write latency, snapshot capability, high availability. All these are the feature sets. Some of the tiers have it, some of them don't. So based on the requirements of your VM, you can, and if you create the appropriate policy, the VM would be placed on the appropriate data store, and you get that level of service for that VM. So if you look here, we're creating 3 different storage policies, each bound to the different data stores we added. And so when we actually, in the next step, when we actually create a VM from an OVF template, or we create a VM from a template on the data, and we can choose what storage policy that the VM requires. And you can, based on the storage policy, the VM is placed in the right storage, and the storage admin doesn't need to worry about it, because if the storage says that it has all these capabilities and it matches up with what the user has asked for. So that's kind of how storage-based policy management, where the storage vendor exposes those capabilities to the virtual array, and then we see it here. And so as a virtual admin, we are able to do all these, which we couldn't do in the past. So that's very important. And so in conclusion, we've shown you that vVOLS are a game changer for virtualized databases. They gives you trustworthy and seamless backup and recovery. They give you simplified cloning, and they also provide you effective and consistent storage level policy management, right? And so last but not the least, I want to kind of acknowledge the team. The SANBlaze will talk about a little bit about their solution. Without them, we could not have done these demos or done this proof of concept. And then we also want to thank Tina from VMware team for giving us the demo.
Thank you.
Yeah, next one.
Just a quick word on the emulation capabilities of our product. Basically, they wouldn't have been able to do everything they did in a couple of weeks of time without our emulation tool. Basically, we are one of 5 certified VMware targets that can be used in your development process when you're trying to test for things outside the bandwidth that you want to make sure works before you implement into a real-world environment. We give you that capability. It was definitely shown to you here in the demos that they so graciously allowed us to participate in. And basically, we can bring to the party a forum for you to do a lot of your testing before you go live with this system to make sure that it works, and without any risk to any real critical data that might cause you problems if you lose it, if it crashes, if it goes away. We support all the VMware storage APIs, VAS 1.1, or 1.0, 2.0, the VIA, and the vVOL. And we're happy to help any of you out there in the development world, either on a system level or a target level, driver level, whatever it might be, in making sure that your end product that you release to your customers works and is solid. And we can do that very capital cost effectively without having you to set up and buy all the hard iron, such as an Oracle or a NetApp system or what have you. So with that, thank you, folks.
Thank you.
And if there's any questions for any of us, we'll be here. Feel free to stop by.
Yeah, please.